It's been quite a long journey, and I really love it here. My job is kind of hard as department head, but I didn't realize you have to work as department head. But I want to say that I'm very excited about this center, as I'm going to mention in a slide. But in my intro here, it's a very diverse interdisciplinary audience here. So I wanted to talk about a kind of a big question that's occupied my mind over the last couple of decades, which is what is happening to cultural evolution now? Like I said, I started out studying cultural evolution in an archaeological or prehistoric context. And over the years, one of my favorite figures, although it's just schematic, is from a book by Eric Beinhacker called Origin of Wealth. And you may have seen something like this where it just shows some metric. Here it's world GDP per capita, but it might be something like tool complexity or something like that. And the time scale here is on a human evolutionary time scale. And it just shows how any of these changes that we talk about, whether it's the wealth of choices we have, the wealth of technology that we have, the complexity of our culture, it just looks like a right angle in the last century or two. And the other thing is that about 20 years ago, I was excavating at Harappa in Pakistan, which is one of these grand old excavation sites, 2,300 BC or so, contemporary with ancient Egypt and Mesopotamia. And this is one of the famous trenches there. Huge teams of people. And we're excavating things out of the ground from 4,000 years ago, like this bangle here or some of the pottery. And we were also seeing the same kinds of, the same kind of material culture in the modern town of Harappa. And so, we always ask so often, why does culture change? And at that time I was thinking, well, why does it not change? Why and when will you see stasis and such conservatism like this? So before I give my talk, I just want to mention that I think, like I said, this is a very exciting development, this center, and my whole journey through the United Kingdom, through UK, was through I always had my day job, so to speak, as an assistant professor or later professor, but I was always part of one of these funded centers, very much like this one. The first one was at University College London, called, the mouthful of a title, Center for Evolutionary Analysis of Cultural Behavior. Two of the founders were Stephen Shannon, a Bronze Age Neolithic archaeologist, and Ruth Mace, an evolutionary anthropologist. And this is blurred out here, but some of the people on our steering committee included Robert Boyd, culture evolutionist, very well known, and Russell Gray, who's now the head of the new Max Planck Center for the Science of Human History in Jena, and many others. And this itself was a couple of $1 million grant, and then we all got another one to extend it for another 5 years. This one we called the Center for Evolution of Cultural Diversity. And I'm just showing a few people that have been influential on me along the way. And this is geneticist Mark Thomas, and this is applied mathematician Anna Candler, both in London now. In the meantime, I go to Santa Fe Institute Summer School, and I meet a geneticist, Matt Hahn, who helped me with neutral drift kind of papers that I'm going to show. And I move on to Durham, and we got over $2 million from the Leverhulme Trust on a project kind of similar to this group here. We had people from all over: mathematics, geography, climate change, history, banking, and particularly Camilla Sayado, the applied mathematician, who I've done a fair amount of work with. And that was in 2009. I did a sabbatical at Northwestern Institute on Complex Systems at Northwestern. And then I moved to Bristol University, where they had a Center for Complexity Sciences. And they too had, I wasn't part of the grant, they too had gotten several million for training of PhD students. And one of those PhD students is Damien Ruck. And he'll be, I became his co-PhD advisor, and he and I have worked together, and he'll be one of the postdocs working for this center come August, because I was given a postdoc with my job here at UT. So that's a bit of it's a bit of an intellectual history in a way, but to show that I really believe in this interdisciplinary subject. Now, where we come at it from anthropological perspective is a few realizations that have really been, baked in over those decades. And the first is that we're a social species. Now, some of these things I want to put out here are actually fundamental debating points about when you get into actually how does culture evolve, how our decision make. You might get some who focus on rational actors and independent costs and benefits or objective costs and benefits of certain decisions. And in other situations, you have people who argue, and I'm not going to argue either way. I think it's case specific, that all decisions and most of culture has a social function, and decisions are usually made socially rather than independently. And it was years ago that Robin Dunbar made his famous, it was 1992, I believe, that he made his famous realization that if you look at the proportion of the brain that the neocortex occupies and the mean group size of the primate group that you're looking at, there's a rough correlation, and it was actually taking this correlation out to a group size of about 150, where he made his the famous Dunbar number was realized, that human groups tend to max out at 150 relationships, or else you need some sort of hierarchy or fission between the groups and so on. And meanwhile, over the years, numbers of different kinds of neuroscience articles have come out. Here's one from Science showing that the parts of our brain that experience pain and pleasure physically are also the same parts of the brain that tend to experience social inclusion or social rejection. So there's a lot of evidence that we really are a fundamentally social species, that our very brains are evolved to be social. And I thought it was interesting that Pew did a study on Facebook, and here's a graphic from a Pew study a couple of years ago. A typical Facebook user has 145 Facebook friends. I thought that was remarkable, that it would just fit that, just about that Dunbar's number. Instagram was actually, they listed as 150 friends. The other thing that was baked in, probably from Ruth Mace's work on cultural phylogenetics over the years, is that much of what we do and how we speak and our behaviors are a lot older than we think they are. Little Red Riding Hood, for example, the fable, is a worldwide fairy tale, and it's over 2,000 years old. But with the thousands of years ago, maybe 8,000 of years ago, there was the spread out of Anatolia of Neolithic farmers replacing the hunters and gatherers that existed in Europe before them. And they presumably brought with them a Proto-Indo-European language that has since devolved or branched out into the different branches of European languages, but not to forget also Hindi in South Asia. But we often see the map, as you can see here. And many have refined the Indo-European language tree. It was discovered in the 1700s, so it's a very well-studied phenomenon. But one of the interesting things about it is also that along the way you see other kinds of cultural elements were presumably carried along, and you could think about a phylogeny of them as being running kind of parallel to the Indo-European language tree, which diversified as farming and later Bronze Age populations did as well. So here's a depiction on a cauldron from Denmark about 100 BC. You can see a sort of godlike figure here with crossed legs. And here you see a seal from 2000 BC from the Indus Valley. I actually found one like that in 1999 as part of my team. It was very exciting. But the similarity here you would not probably ascribe to convergent evolution or something like that. It's pretty clear there's some kind of common ancestry between the two of these that predates everything else. So in a recent book that we published last year, which is kind of a general reading book, we just wanted to ask a really big question here is, in a cultural world that evolved like this, how do we ask questions about where culture is evolving today? And at the risk of oversimplifying, but I really want to ask a kind of big question here, is we often, rather than a one-size-fits-all kind of a model about what's happening, we want to ask a couple of questions first about the transmission of culture. So the first one is, how deep is it? The slide here I'm showing, these languages and traditions were learned from parents. And it's a very deep form of cultural transmission, learning from parents one generation after another, so much that Rob Boyd and Pete Richardson would call it guided variation, for example. But the other is, how wide is it? What are the networks that characterize the cultural transmission? What bottlenecks are there or have there been in that cultural transmission over time? And crucially, as I'll get to, what is the nature of cultural transmission? Is it something social? Are we spreading it horizontally, so to speak, from one to another? Or are we learning it by ourselves and working out some solution by ourselves, or responding maybe ourselves to information that's brought to us, that's disseminated to everyone, but we have to respond to those informations ourselves. And you can see examples of cultural transmission that are very deep and narrow. So here's an Acheulean hand axe, which didn't change much for 1 million years of human history, hominid history. Here's a decorated canoe paddle from a Mesolithic site in Denmark about several thousand years ago, and there's a fish hook. But these decorations, painted decorations on this wooden canoe paddle, would surely have been learned from within the kin-based cultural group. But to contrast this with so many things that we see today, like vaping or anything else, a 19-year-old will probably have a different social media preference of a platform than a 13-year-old, than an 8-year-old. This intra-generational change we're seeing right now. And this graph, you won't be able to see it, but that's percent, and these are people who have ever tried an e-cigarette, and there's a vast difference between young people, 16 to 24, and 25 to 44-year-olds, and so on. It's just a demonstration of great difference between generations, or even less than a generation, and compare that with a world in which we evolved, where things change so slowly you would hardly have detected in a lifetime. Another assumption that we make, though, in culture evolution might be that culture is adaptive. Joe Henrich is famous for his work that argues that, and rightly so, that prehistoric culture is adaptive, that culture adapts in parallel or in concert with the people themselves, and usually turns out to be quite useful for the environment. So here's Easter Island, and it's been shown recently that the colonizers of the Pacific had a agricultural subsistence that they got from their ancestors in Southeast Asia, a terrestrial agriculture. But Easter Islanders at the far eastern edge of the colonization of the Pacific settled about 800 years ago. By this time, the culture had adapted, and they were maritime adapted, and they actually so they ate seafood. They learned how to fertilize these soils, and crucially, they did not deforest the island. Actually, the rats that came along with human colonization are responsible for that. But so culture is adaptive, but then I would ask, is it? Is culture always adaptive? And we have many situations, you can probably think of your own, where behavior is changing in a way, like the obesity epidemic today. You'd be hard pressed to argue that it's really adaptive to the present environment, natural economic environment. And this is just a map of US obesity just in 25 years, from a case in 1990. All these colors are the rate of obesity in the population by state. And again, the legends are too small, but all of these states are less than 15% obesity. By 2015, all of the states are well above 15% obesity, and well into some of them into 40% rates of obesity. And so any state here in 2015 would be an extreme outlier, just as recently as 1990. So we have to ask, what does it mean for culture to be adaptive in the modern age? Another, and I took an excerpt from Hilary Fouts and Emily Tucker's article for today. I was looking at some of the new members of this center, and I found an excellent example of a decision concerning prenatal physical activity and also breastfeeding. There were nice examples in there. But we often want to ask whether a decision is made in the face of very transparent payoffs. So here's somebody who chooses to exercise because she feels good and she knows the health benefits. Very clear benefits of exercise. We know more or less what it does for us. But a lot of decisions in this world are made where payoffs are opaque, or maybe they're just non-existent. So here I am in Denver with my son years ago, and I carried him the whole trip, and I was really annoyed here because I'm looking at a wall of insulated coffee mugs, and if you think about the dynamics of my making a decision here among all those coffee mugs versus over here, it's very different. Another example that I've done some work with is baby names, because the data were so good. And again, you wouldn't argue that there's a discernible payoff difference. And so I'm taking some time to lay this out because I do think this is an important distinction in how we approach cultural transmission and change. And so if we think about these two phenomena as an example of different ways of thinking about cultural change, in the case of obesity, we might start by arguing that the cost-benefit landscape of acquiring calories has changed dramatically. In short, calories have become very cheap, and so the obesity epidemic has most strongly affected the poor. And you can see that with a plot in the United States. These are the 50 states in 1990 and 2015. Here's median income for the log of the median income for the state, and here's the obesity rate. In 1990, there was no discernible correlation between those two. And then by 2015, there was quite an obvious reverse gradient, it's called, because it's the poorest people that have the highest rates of obesity. It's the opposite of what you would find in the developing world, where wealth equals an ability to gain body mass index. And every year in between, this correlation grows and leads towards that one. But on the other side, let's take something where the costs and benefits are not obvious at all, how you choose a name for your child. And there was a situation in 1960 where, now these maps show the most popular name in every state. So all these red states where the most popular name among girls in 1960 was Mary. And here is 2009. And by 2009, you have a number of names, Isabella, and several others, and it's more of a patchwork quilt that you can see between 2006, 2009. And among boys, every state, the top 5 names were from the same group: David, James, Robert, John, and Michael. And everybody west of the Mississippi practically was named David. And by the time you get to 2009, the most popular name in Minnesota, I knew he would look up when I said Minnesota. We have a Minnesotan from here. We also have someone from Wisconsin, I believe. The top name in Minnesota was not even in the top 30 in California. And that's a situation now where we had homogeneity at one point and extreme heterogeneity at the other point. But I would argue that this difference here came about just by people learning and copying those around them, and you had a random drift effect that led to different cells or regions of similarity. Now, why is this important? Because we might later tack on a sense of identity to these things. Oh, they named their kids Logan in Minnesota, so I'm not going to vote like them, or I'm not going to. You know, you could see, and we all know how nowadays beliefs and ideas are all seem to be packaged together in sort of illogical combinations. Well, what if drift is maybe the starting point? But the point anyway is not to debate the ins and outs of this, but to make the point that this dynamic is an important one to think about when you're thinking about the way that culture is transmitted. So just to sum up what I've said, one axis that my colleagues and I like to think about now about how decisions are made are they made individually or are they made socially? This dates all the way back to Boyd and Richardson and before. And here's a list. There are biases that you might have as a social learner. Kevin Leyland, behavioral scientist at St. Andrews, has listed several. You might copy the majority or copy something that's better. You might copy your kin or your friends. There are different kinds of biases that we might have to our social learning. But if we learn something individually, then we're just doing trial and error on our own, or maybe we're just guessing. I mean, if any of you have, you know, when I got here and I got presented my options for my 401k, you know, I just said, I'll take that one. I had no idea what I was deciding between. And in other words, my payoffs were extremely opaque. Not only were there dozens of choices of 401k plans, but I'm trying to estimate a payoff 30 years in the future. And so my colleagues and I like to impose a second axis on this way of thinking, and it's the extent to which the payoffs of the decision are apparent to you as you're making the decision, or you might say effectively are they apparent? You know, if I think I know but I actually have no idea, it would be down here. And we first set this out with actually an economist, Buzz Brock, up at Wisconsin, because he had been modeling decision-making the same way. He would call it discrete choice under social influence. And later, Camilla Sayado, whose picture I showed in my second slide at Durham, we later extended this. But the essence of this is to think about behaviors not in any one-size-fits-all, but on a landscape like this, where you're thinking about the degree to which people are making decisions individually versus socially, and the degree to which the payoff, and that includes these social biases, are transparent or opaque. So if I see the obvious expert in my community or the master from whom to learn, that is a transparent and social situation. But if I have no idea who is most expert at something, or if I just say I'll have what she's having, point to somebody in the room, I might be making social decisions, but they're under they are opaque in terms of payoffs. So here I mentioned Joe Henrich, but Joe Henrich works in the field, and here's a paper by Corin Apicella and others. These are anthropology works. And one of the nice outgrowths of this kind of thinking has been to go out in the field and actually, rather than just doing ethnography on what people do, you ask them about where they do their learning. So Henrich and James Broche asked questions like, who's the best expert on yam cultivation? They asked these in the beautiful Yasawa Islands of Fiji in the South Pacific. And they draw a network, and you can see that many of the individuals asked are referring to one person or a few experts within the community. The point being that it's well known who is the expert. Who would you learn how to do something? There was a different network for fishing. There was a different network for medicine, for example. Each was different, but each had clearly defined hubs as people who were experts on one thing or another. And this relates to some work in this group where we think about the capacity or the propensity for a cultural selection versus drift is going to depend to some extent on the hub and spokeness of that network. And here's another example of just a study where they did the same thing, the same kind of thing. They asked questions about gifts being given between hunter-gatherers among the Hadza of Tanzania, Goronapacella and Kimhill and others. And one kind of interesting thing that came out of this also was that hunter-gatherers, males might encounter 1,000 other males in their entire lifetime. Now we know people who have 1,000 people on their, maybe on one of their social media followers. So it really is an extraordinary time that we live in, where if we evolved in social groups where you might meet 1,000 people in your lifetime. And here's an example of why I think we really want to think about this, because a lot of our choices in the past were made with well-defined experts and with transparent payoffs, because if you didn't make choices with transparent payoffs, your group would probably perish. And also, culture was evolving in a way that had already searched the landscape and found good ways of doing things. Joe Henrich, again, his work shows many examples of that. Cooperative ethics in whale hunting societies versus more individual ways of playing economic games in hunting and gathering societies. It's adaptive in either sense. But now, in one of my classes, I asked students, what's the first thought that came into your head this morning? And it's probably something from a Facebook feed, and it might be about oatmeal or soap or something that somebody did. Facebook is in the news a lot lately about the data they store and also the way they try to get more people looking at websites. And this isn't exactly what their algorithm is, but I took this is approximately the kind of metrics that Facebook think about when they generate, when they try to get newsfeed visibility and customize it to an individual user. The interest of the user is but one variable. Popularity is one of the most important ones, and so is recency. And these are in direct contrast with what I've been saying about prehistoric culture, learned from parents or kin groups the same way generation after generation. So it's really antiquity that characterized much of our cultural learning in the past. And popularity in and of itself was never the metric. It was expertise. It was that person may be the most popular, but that was not the variable in and of itself. So we are now making choices we're often making not just many choices, but in many cases an overwhelming number of choices. Very difficult to be discerning about our choices. So the payoffs are often opaque about what we're deciding. There is an extreme recency bias. As we all know from the last 2 years, it seems like the news story of the day is not anything like the news story of yesterday and what everybody's talking about, if we consider online discussions to be what people are talking about. That's not the be-all and end-all of culture, of course. And everything nowadays is ranked in a top 40 list. And again, that has I can't think of any way that articulates with our evolutionary or even more recent past that things would be ranked in this way by global metrics. So where does this fit with some of the modeling that is done by people in this group or with evolutionary modeling? Well, one of the papers that was seminal in this was the Martin Nowak and Erez Lieberman paper in 2005. Where I was delighted to see this because we too had been exploring so-called neutral models of choice in comparison with archaeological data, and then this came out and it really helped to legitimize it. And the idea is that we look at a group of population, we look at a series of time steps in a model, from an initial population to the next time step to the next time step. And this is it's 4 actions here, really, in just 2 time steps from beginning to end. And we only have, and this is crucial, in this case we're only talking about 2 choices. You choose the black shirt or the white shirt to wear tomorrow. Or to teach to your child. Your child is just going to wear a shirt or something. So it can either be intergenerational or it can be from moment to moment, depending on how you want to think about it. But so in each time step, and those of you who are in ecology will know the Moran model, but I'm just spelling this out, that you select one individual for reproduction, and one for death, and then you replace the one that you kill off with the one that you've reproduced. So there's absolutely no there's no bias between either of these two colors. It's just a random replacement process. The difference with the kind of modeling that we were doing at the time, and these papers are from way back now in 2003 and 2004. There's the one I did with Matt Hahn. We started out by looking at baby names. And baby names literally are intergenerational, but we said, let's imagine a population at generation 1 or time 1 where all these different colors are the different names or whatever they are, pots or ideas or whatever have you. And in this case, there's only 2 individuals here with the same trait or same name, and the rest are different. So the numbers are the individuals, and the colors are whatever behavioral trait it is that they've adopted. And then in the next generation, we just do this over and over. We each and every one of these 10 individuals selects or copies something from the previous generation, except for one here who invents a new variant. Then that new variant got lucky. It was copied. Individual 9 copied individual 4. So that new variant survived to another time step. But you'll see some of these variants go extinct. Like by this time, the orange variants, just from pure luck, never got copied again. And so they're gone by time step 4. And this is all it is. That's all this Fischer Eska model is of cultural drift. That's all it is that we used. And we have a population number, which is 10 individuals, and a mutation rate or an invention rate of 1 in 10. And that was it. But what you see here going on, I'll show you in a minute, is there is a flux of what is most popular. There's a flux through the population of variants. It never goes to all one variant like you would have with no invention, because the invention keeps adding new variation to the pool. And if it weren't for that, it would all go to be one color or the other. And this model with variations has been used for all sorts of things. The premise was not that this explains everything that's going on, but the premise was to provide an alternative to the prevailing kind of theory about how choices were made, where that this prehistoric projectile point was optimal in terms of its performance attributes and being a spear, and as was this pot, as were these baby names, as were these bird songs, and so on. And the point that we were exploring through all these papers, many of which are people I collaborated with, others are other people looking at other things, choice of words on Wikipedia, for example, is simply to say, how far can we get trying to model kind of the opposite, which is just random copying with invention? What kinds of patterns in the data can we represent? Well, one of my favorite, I would show you the one with the baby names or with archaeological pots or something like that. I'd be happy to show that another time. But James Gleason over at Limerick University actually did a very nice paper in PNAS a few years ago where they modeled Facebook downloads in this way. The one difference that they had is I was showing you a model where you just copy from the previous time step. They had kind of a sliding window, how many time steps, how much memory you have, how many time steps back you can copy from. And there are what's nice about this is it captures several aspects of the data. The first one is that you always have a highly right-skewed distribution of popularity. So that's a log scale of popularity, and that's a log scale of how many apps have that popularity, and it's a cumulative function. But Amazon sales or popularity of Facebook personalities or apps, popularity of Twitter, well, that's log normal, but it's highly right skewed. Popularity online is always highly right skewed. It's not normally distributed. There's no mean to it. And we found the same was true of baby names, as you saw, for example. Mary was millions of times more popular than say the bottom of the list. But the other things that they represented was also the turnover, the constant turnover within a top 5 list. So despite people copying just at random, and despite the fact that you get a natural advantage from being more popular, because the more popular you are as a trait, more likely it is that you'll be selected, nevertheless, there is a constant turnover in the top 5. So this is measuring how many variants, when you rank all them by popularity, how many variants are being replaced over time. It's become an established aspect of the neutral model that it has this constant turnover in the top 5. So now it's actually, you would think like to try to impose a model like this on how we choose our words and language would just be absolutely preposterous. But here's a paper from Nature in 2017, and Joshua Plotkin was the lead author on this. And what they were doing, what I show here, is that now we have, this is a kind of a graphic from the Google book scanning project. I believe this study was using Project Gutenberg, which is a great database. But we now have data on word frequencies in multiple languages through many centuries. So it's possible to look at these patterns, but this paper went further in trying to model it. And I'll just read here, this is something I never thought I would read. I reviewed this paper, by the way, which is, it's listed on the paper, so I'm not giving any away information, but it says, the understanding that gene frequencies change at random by genetic drift, even in the absence of natural selection, was a seminal advance in evolutionary biology. Stochastic drift must also occur in a language as a result of randomness in how linguistic forms are copied between speakers. And here we quantify that, the strength of selection relative to stochastic drift in language evolution. So this was the original purpose of the neutral model being introduced to cultural transmission studies, which was not to say that this is how it works all the time, but to introduce something as maybe a better or more effective null model than the opposite. And that's what they were exploring here. And I want to just show our own, Damien and I worked on this with word data as well, and I want to show how far we got with the neutral model with word frequency data. But before I do, I just want to point out that we actually got stuck. We weren't able with the basic neutral model to replicate all the patterns that I'll show in a minute that we found in the word frequency data over a century or two. Just getting all the frequencies of all the words over the 100 years of our data set, or 200 years of our data set. And that's the realization, coming back to the Lieberman paper, that the nature or shape of the network, if people are all connected to their neighbors, or if they're connected randomly, or if they're sort of mixed very well, or if they, and this is back to that Nature paper, if all are pointing to one individual, not too far cry from the traditional learning networks I showed, or you might have a network where one person is providing information to many others. All this matters for how strong selection can be on the choice of things. So let's say, and here's an example from an actual experiment with participants, 96 players, where they were put in different networks, and only in one network, the homologous mixing case, was there a solution to a problem that was then shared with others and becomes the social norm in the population. The other ones just kind of floundered around in this way. But I wanted to come to this one because this looks like prehistoric networks sometimes, they're very funnel-like, and yet maybe a more random network is more characteristic of where we are now, or maybe not, but that remains to be determined. But we used a bit of this to help us get through a problem in our representation of the books. And if we go back to that kind of schematic that I showed you between payoff is obvious, payoff is not obvious, or we're well informed or poorly informed, or learning individually or learning socially, you might look at you might have a kind of a network depiction of that as well. This might be a case where lots of people are learning from some others, or this is a case where the learning is very well directed through the generations. Here's where we're just choosing, we're not connected to anyone and we're just having to pick at random, and here's where we're totally on our own, but we're picking on our own, but the choice is obvious, and also very often the choice is not super numerous. Okay. So when we applied this kind of analogy to the book corpus, we had years of data, so we had 300 years of data. We had the size of the number of books, this is in millions actually. In the Google book corpus, thousands, sorry, and it grows exponentially. So we had a model where this number is not constant. This number is growing of number of individuals. So the individuals are now like the variants are the words instead of being colors or something like that. And through time, the numbers of words in the entire corpus is growing, and we make the preposterous proposal that in every year, all anyone ever does is just choose their words at random from the previous year, and we see how it evolves. Now we know that isn't how words are chosen, otherwise our sentences wouldn't make sense. But nonetheless, we want to explore this, and you wouldn't be surprised if we couldn't capture all those patterns of the right skewed distribution, the turnover, and the way the individual words changed in their frequencies through time. So we get a little bit of insight about imposing some kind of a network structure on this, just in the sense that we said, okay, people are not all reading random books. Many of us read the same books. So we just, for the sake of a model to learn something about the process, we propose that there might be a canon, a small subset of books that just about everybody reads. When I was in my 20s, I aspired to read the New York Times Top 100. I forget how many I got through, maybe 20 or 30. But I still have to finish that before I die. But there are 100 books that I know of, and I know a lot of other people know of, that we kind of aspire to read so we can have conversations about the same books and call ourselves learned. So we just proposed that there would be a canon. So instead of just copying at random, all the other books are sampling from this canon, which is itself evolving, but it's kind of a closed. Our paper's out, so we can discuss how we did this and what we didn't do right and what we did right. But all eyes are kind of looking towards one set of books. And that did help us capture a lot more patterns than we had been able to capture up till then. So here's the famous Zipf's law, for those of you who know that famous law, but it's the relationship between the log of the word usage frequency versus the proportion of the different words that have that frequency. And so the is up here. These should be all negative exponents. So the most popular word is there. Other way. The is down here, and the rare words are up here. And most of the words are rare. A few of the words are very popular. Lots of models can do this. That's not extraordinary. But we got more encouraged when we were actually able to capture aspects of the turnover. So we looked at the top 5 list of the most popular words in English in 1700, 1710, 1750, so on. The top 20 list, the top 25 list. We made all these different lists, and we were able to get much closer to the decline, the sort of the slowing down of the turnover. So the top 20 list of most popular words in books, most written books, words in books, was turning over quite rapidly in the early 1700s. And again, there are causes we might think about that for that, like the different purposes of books over time, and so on. And again, we're just trying to see how far we can get with this, so we have something to talk about with respect to how well an approximation this neutral model can be for something like this. Another thing that we can do is compare the size of the list with the turnover, and that tends to be linear. We were able to get that pretty well. And then here's something that was really bugging us. We could not get it. And it was the relationship between the corpus size, the number of words, the bulk number of words that are written in different years, and the number of different words, unique words, which is much smaller, the vocabulary size. So the word "the" would have billions and millions of copies of it, but it only counts as one vocabulary word. So this is the relationship between the number of words in the sample per year, in each year, and the number of different words. And that's actually roughly a square root relationship, that the vocabulary size grows roughly with the square root of the corpus size. And we couldn't get anywhere near that with the traditional neutral model, but with this, we call them the full model and the partial neutral model. But we were able to get it with the partial neutral model. So again, that's just an example of the specific kind of question we were asking. But to come back to this bigger question, why am I spending so much time trying to model word frequencies in this way? Well, it's because I think that the time has come actually for the neutral model. We didn't used to learn this way. But now there are facts such as, the 1 million people who Facebook Save Darfur on Facebook, 99.76 of those people didn't make a donation to the actual cause. And we have pictures like this. This is from Beverly Strassman. Here's a traditional menstrual hut from the Dogon among the Dogon of Mali, and in the background is a mobile phone tower. So the dynamics of information sharing obviously changing very much, and we're entering the realm, as many of you know, where many of the agents online are not even human, and what they're doing is a great deal of copying with mutation. So if we're not doing the neutral model, these bots surely are. And so one application of these kinds of approaches may be to try to recognize artificial posts as opposed to real human-produced posts, that kind of thing. Okay, anyway, I close just by noting that I was very interested and excited with the work of many people in this group, and I think there are lots of overlaps that I didn't get a chance to mention, and the extension of those NOAC neutral models here is connected to this group. The discussions about payoffs, Sergey has just published a PNAS paper on that. We haven't talked about prehistoric networks, which archaeologists are good at kind of mapping out, and we haven't talked about social diffusion. But all of these are great subjects that I'm excited to talk about with people. And thanks very much. And I'll just close on some of the other kinds of data sets that anthropologies can offer to this kind of a study. Thank you. You want to start, Sergey?
Yeah, I can.
Yeah.
So thinking about these ways, you have such a flexibility in thinking about sort of how to structure a network and yet keep it sort of in some sense neutral. Am I right in that?
Yeah.
Okay.
Yeah.
So then, I mean, given that that ability, how would you ever maybe potentially reject a neutral model, given that you can sort of have those degrees of freedom in being able to create an infinite pull from an infinite set of sort of social networks?
So you mean we're taking such a leap by just assuming a fully mixed network and a particular kind of model? How do we know that that's the one that's actually explaining?
No, I guess maybe I'm misunderstanding.
Yeah, no, go ahead, Michael.
Maybe I'm misunderstanding some of this, but there's different ways you can structure a network, right? Where you could have, in some sense, not have selection, but just have these differences in the network structure. And things could diffuse in a particular format, or have a particular have properties that mimic the data.
Yeah, I see what you're saying.
right? And so I guess my only question is like, well, if you had somebody who was a diehard neutralist in this framework, couldn't they find essentially they could always find some structure where like, see, there's no reason to invoke selection.
Yeah, that's I think that's the frontier of this is to so if I get you correctly, you might say I actually have a process here where selection is taking place, but I'm going to put it on a network that's going to give you the same result. That's a new paper. That's great. That's why I'm here. Yeah, I mean, that's a great question. But at least now we have something to show you. Like, this is what we can get with just this neutral model. But that's an excellent question.
So you started mentioning books in the 100 best books in the New York Times list. Have people actually looked at influence of specific books, not words, but the
Within.
Right, that's mentioned, for instance, how Shakespeare has had such a great influence on language and the King James version of the Bible, and you can look at how Darwin influenced Darwin, and I've been noticing over the years recently how a few of the students that I have actually are reading any of the good big novels, Dostoevsky or Tolstoy. They don't even know who these people are really, or have read many of the undergraduates that I've come to. They're not reading things like in high school and so on, and that should change these networks in a very quick, culturally dependent way, perhaps.
Well, yeah, and there's so much now that being done with these book data since Google Ngrams put out their gigabyte files in 2010. David Krakauer, the former president of the SFI, or I guess he came back after Wisconsin, but he's interested in whether you can recognize a writer from the particular statistical patterns of the content-free words that they use. Not the nouns and the verbs, but the ands and the buts and the thus. He does a lot of work with that. And others, the paper I showed you there by Newberry, they were looking at the regularization of verbs over time. Mark Pagel has looked at the speed of, Mark Pagel's a phylogenetics kind of guy at Reading, but he's looked at the speed of turnover on these in different categories of words over hundreds of years, adverbs, nouns, and it turns out that the more words are used, the slower the turnover actually in that paper. That was from 2007. But yeah, and so before the Ngrams, people were using the Gutenberg. But the thing is, you think about some of the capacities of the researchers in this group, and you have these wonderful data files of not exactly, but precise numbers on how often each word was used in each interval of time. And it's very much like, in my opinion, like a genetic data set. And I think some of the applications include recognizing artificial speak from natural speak, looking for, without knowing, can you actually find Shakespeare by looking at the patterns? Do you see suddenly a sort of explosion and diffusion of new words in 1600 or so without knowing? I mean, that would be an easy one because that is what happened. But a lot of his words went extinct. So there are all sorts of things you could do. And I think we create a set of templates that we can then use to compare real data to in an automated way and rule out different models and try to automate some of these algorithms to pick out events that might have escaped our notice in history.
So first of all, David Krakauer was on our advisory board for a while here at NIMDS. And then he moved to SFI and all hell broke loose and he didn't have any time to do anything. But so I have two questions. I'm trying to phrase them together, but I kind of realize that they're two different questions. So one is that if we were looking at this 30 years ago, thinking back to my education, much of what you've talked about is really data-driven. I'm sitting on, right now, a National Academy.
Is really what?
Is data-driven.
Yeah.
And I'm sitting on a National Academy panel, committee that's looking at data science education and trying to figure out what it is that the future holds with regard to understanding how to do what you have shown us. Okay, And my bet is that what you are at the tail of the distribution generally in the field of anthropology, I would guess, in terms of quantitative use of data in the manner that you have. How do we move forward, okay, to enhance learning? So this is the second part of this question. How does learning interface with the variety of social network changes that you have documented in a wide variety of cases?
So that's a great question, and I teach a class in anthropology called Big Data Anthropology. We're meeting tomorrow, and we're going to try to generate those distributions from some word data. And I'll be honest, I don't teach them in the beginning a lot of what they're actually doing. We just do it because it's in R, and you can just do it. You can map obesity, and we get it done in an hour. And then I feel like that's the hook, and then they get interested in actually trying to find, well, why did we get Zipf's law? And the other thing that I think that people are realizing is that it's so much easier now to work together. So if, I'm not a very good coder, but I can put something together, especially the kernel, the equation, into R, and then share it with somebody who's a very good coder. A lot of my work there. And I might be talking to somebody who actually understands people better than I do. And we make this chain of knowledge, and it's getting easier because of the ease. There's or we might start with the mathematics. That's what Buzz Brock is a mathematician, and then I coded it, and then Camilla is both a mathematician and a coder, and it's kind of you just can't work alone anymore. It's very difficult. One of the anthropology papers in this group I thought was brilliant because of the clarity of the choice that was being made. So this includes ethnography as well. When you get all the way down to the ground, it's those ethnographies that are describing whether we're right or wrong. Oh, excellent question.
Can I ask a question?
Yeah.
So kind of going back to your introduction and the title. So why you think culture is evolving faster now? And why people make decisions differently from what we used to do?
Why do people make decisions differently?
And why culture is accelerating?
Well, we could, just to make the question easier, we could suppose that everybody was identical, but making a decision after you've fallen out of a boat as compared to choosing a name from among 50,000. So it could just be or me trying to choose my 401k. So we don't even have to suppose any difference between the individuals. In one case, I have no concept of the costs and benefits, and it's just going to be a random choice process. In another case, I think the selection is very, very clear. But then there's the other. You have in betweens where you have the difference in the different structures of networks, and then you have, if you want to keep going, then you have the actual differences in people and how they make decisions.
Alex, sorry, but
yeah, sorry.
Just looking at the 60s and 2010, right?
What's that?
Well, you showed big differences, like in how people choose names.
Yeah, yeah. Yeah, deliberately.
It's not like 50,000 years difference, it's just one generation. So why things change much more rapidly now than, say, 25 years ago, 50 years ago?
Oh,
Do you want him to answer this? 'Cause
yes.
Your center is
Well, that was the
No, that's
that was the title of his talk.
okay. No, excellent.
Accelerated culture evolution. Yeah.
That's a brilliant question. So to take the names, for example, now I'm not going back 50 years, but just 100. 100 years ago, boys in East London were named after their father. It was about 60% of boys, if I remember the study, a study in East London. About 40% of girls were named after their mother. By 1930, those percentages were roughly zero. So what we have done, in my opinion, in the last 100 years, is we've gone from a world where vertical transmission was how we learned a lot of our behaviors. We learned how to, or if you go back farther, we apprenticed in our occupations. We learned our names. Names were family names. Our behaviors and our ideas were learned from the parents, and of course language. And we've entered a world where much of the learning is horizontal. And I think that's a fundamental difference. And when that transition happens, I think depends on the particular behavior. With names, it was mid-century. But I think with facts, I won't finish the sentence. But, where do we learn our facts now? And I think it's important to tune into. I learned all my facts from my dad and my mom. I'm being facetious, but I'm trying to make a point.
I think this really follows up on Sergey's question. So I thought you drew this really interesting connection between high popularity or learning from the canon, right, with high turnover. Or maybe I missed something, but why are those two connected? I mean, I intuitively think they're connected.
Low turnover. Our turnover was too high until we did the
Okay,
canon.
so it's a low turnover.
Yeah.
Okay.
So we cheated a little bit by making that new model, but yeah, we're trying to. It was linear before, and then with the canon, it was square root. The larger the number of words, this was the number of vocabulary.
Yeah,
Why was the turnover slowing down over those 300 years?
Well,
So I'll tell you the two theories. There's one paper by Alexander Peterson and the MIT group that just says we learn how we use words over time when we get used to them. That was essential. So they had a function to the words. And with our canon model, the slower turnover was a function of basically the corpus getting large with respect to the canon. So the canon is a fixed size, but the corpus is growing exponentially. So you can imagine when you're at the top and the corpus is huge, the turnover it's much more difficult to unseat you than if the sample's very small, because drift is more important when the sample is small. So it was actually just the exponential growth in the corpus.
Can you make a comment on any data sets where the network is sort of understood or recorded in the data set? So maybe something that records the spatial distribution of where some of these changes occur so that you don't have to rely on sort of an ad hoc network model?
Is that Dr. Chan behind you? Because that in your paper, you guys used the Framlington data set or compared something with Framlington, the health data set. That's one of them. There's one called Bristol Avon. There's a data set at Bristol University where they know every individual. So and who their friends are and whether they smoked or this or that. A lot of the health data sets are very good. Yeah, you're not going to get them from word frequency data. If I think of another one, other than the anthropological ones, like the studies by Corin Apicella out among the Hadza and Kim Hill and so on. But that said, so there are. One of the things we've been trying to do is actually build tools where we didn't have to know the network because we started looking at prehistoric stuff. So, but yes, they do exist where they're very well defined. And of course, what everybody looks at are the citation networks or the patent networks. Those are all very well defined, even though people play games with citing patents, but every connection is supposedly there. So.